Welcome to another session in the Google Cloud Lab. So in this lab, we will do the performing advanced feature engineering in Keras. So let me start the lab without any delay. In this lab, we are going to complete the task, and we will not be much discussing about the theoretical or concept or a technical concept here. So let me start the lab first. So let me log in successfully. So you can see the overview. So we are going to create a workbench, temporal feature columns in Keras, lambda layers, and bucketize and cross feature columns. This is the terms we are going to discuss. So in the Vertex AI, let me click on the Vertex AI and you can see the collab enterprise and workbench. Let me also enable all recommended APIs. So you can see the recommended APIs is getting enabled. So we will be using the workbench for this tutorial, and you can pause the video and go through the contents as well. So first setup is all completed. So I have in from task one, step one and step two is completed, and step three is going to the workbench. Step four, let me create a workbench here. I will give the name as lab workbench US East 1 and US East C. And rest all basically these are default things. But anyway, let's continue and see. I'll give on continue, and in the environment I will leave everything as default and continue, and the machine type is a default, but you can see the machine is E2 standard for virtual CPUs, 2 core and 16 GB memory. I will leave everything as and the disk you can see the balanced persistent disk for data disk, and it is having 100 GB. I will leave as continue. Network is default, continue, and IAM services are default, continue, and system health is everything. I will leave it as default and click on create. So this will take about 6 to 8 minutes to create a virtual machine. So once the virtual machine is readily available, we can see a open Jupyter lab here, and you can see I have created 737. So let's wait till 7:45. In the meantime, you can open the lab workbench and see the logs if needed. It is still in provisioning. You can see the status as provisioning, and quickly you can go to the logs section and you can see the steps that is happening in the logs. And in the system, in the hardware, whichever the selected hardware, this is what it is. And you can see the IP, everything is configured, getting configured by default. It's all provisioning. And also you can see the health status. Monitoring. So let's wait for the status to change to active. Let me go back and we'll see whether that open Jupyter is not yet. So now the time is almost 37, almost 5, took about 5 to 6 minutes. Let's wait for a few more minutes. Now we can see the status as active. So from here also you can open Jupyter Lab, or you can come back to the whole instance view, workbench view, and from here you can click on Open Jupyter Lab. So this will open in a new tab. So once this Jupyter Lab is open, now click on the Python 3 IP kernel. You can rename this IP name as clone grep, because in this only one step we are going to execute. We are going to clone the repository. So while cloning, you can see in the Shift Enter, click on Shift Enter. You can see in this folder structure that test training data analyst will be created, and all the files will be get downloaded. So once the download is complete, then we will go with the performs advanced featuring lab. Okay, this is done. Now let's click on training data analyst, courses, machine learning, deep dive to picture engineering. Okay, picture engineering, labs, 4, Keras advanced feature engineering. Now I will change the kernel to TensorFlow 2-1. Here you can see the step. Second step, click on select, click on edit, clear all outputs. Everything is gone. Okay. For the interest of the time, I will open the solutions as well. But in the steps, without solutions, we need to create. But for interest of the time, I'm selecting the solutions. That's all we have. So basically, from here on, we are going to completely work on the Jupyter Lab. So I'm just pulling out for more visual here. Let me close this. Okay. From here, at this point, you can pause the video and go through the contents provided. So changing the permissions for this training data analyst and installing the GraphViz. And you can see this kernel is in busy, so we have to wait until the kernel becomes idle. Yeah, the kernel is idle. You can go and select. You can see the kernel is idle. Now we will download necessary packages and also print the TensorFlow version. Let's wait for it to print the TensorFlow version. So now you can see the TensorFlow has been printed over here. Now let's create a data folder. So you can see the data folder inside the feature engineering. This is where it creates, and also you can see it just created a second echo. And we are going to download two files. One is train one and one is valid one into the data structures. So let me get inside the data folder and now download, and you can copy that. You can see the copy in few seconds. Okay, and two files has been downloaded. Maybe you can just click on refresh. You can see the two files. And just this is to list the values. So and also list the head values. You can see two files is having fare amount, passenger count, pickup longitude, pickup latitude, drop off longitude, drop off latitude, hour of day, day of week. This is the CSV we have. Now let's create an input pipeline. You can pause the video and go through the contents here. I'm just executing it, and only columns. I am selecting the CSV columns, and label column as fare amount, and the string column as pickup date and time. Numeric columns as pickup longitude, latitude, drop off longitude, latitude, passenger count, and everything is defaults as 0 NA, and days is only Sunday to Saturday. This step is done. Now here we are creating a function to define features and labels. That is the first definition, and utility method to convert to create a TensorFlow data into from pandas. Okay, this two is also done. Now deep learning DNN. See, yeah, we are creating a root mean square error, and this is the baseline model. Now deep neural network. Let's see how the model is created. Now you can see a picture over here. Let's wait for that. Yeah, now you can see input layer having drop off longitude, latitude, passenger longitude, latitude, pickup longitude, dense features, and we have two hidden layers, hidden layer 1 and hidden layer 2. In the hidden layer 1 we have 32 units. In the hidden layer 2 we have 8 units. Both are activation ReLU and both are H1 and H2, and output is only one fare amount, so that is having a linear activation, and it is having only one node. Okay, now so batch size we are defining with the batch size, and now we are loading the train data set and evaluation data set, that is validation data set, with a number of, and we are going to fit. How many epochs we have? Steps per number of training examples divided by batch size into number of evaluation. Okay, it is the value is 5. Okay, now we'll plot the curve. Now you can see the curve at this point. Loss and mean square error. So training model loss and model MEC. Now let's predict it locally. Okay. Now prediction is $7.8. Okay, now temporal feature columns. You can pause the video and continue here. So what I'm going to do is I'm just going to copy from the solutions and paste it over here. The reason is we will have to saving the time. Yeah. Now enter. Now first thing we are passing the date and time, decoding to UTF, and in this format. Second, we are passing the ES value. here type of yes value and separating out the weekday. In the third TS time sheet, now Euclidean distance, calculating the Euclidean distance definition, scaling longitude, scaling latitude. Now let's transform the data now. I know I'm just copy pasting everything here, but I would suggest I wanted you to uh, at least pause the video and go through the code. So this is where bucketized features and crossed columns has been implemented. This is our transformation, and now here we are building the DNN of RSME and DNN model. So model is built. Now build a DNN model into, now calling the DNN model in the model. So inputted features, dictionary keys, transform features also updated, and feature columns also updated here. Now you can visualize the how the data of the Euclidean lambda has got included here. Now training and validation examples. Now let's create this. Now it is going to create 8 epochs, I guess. Yeah. Now you can see all the loss is coming down, as well as the root mean square error is coming down, and mean square error is also coming down. You can observe this. And when we see the plot, we will know the graphical representation of the loss and MSE. Let's wait for that. And just a second, in the seventh epoch, it has gone slightly up. The loss has gone slightly up. Let's wait. So in the baseline, the taxi fare is, we have seen it here, 7.8. This is our baseline. Okay. Now, after the in featured engineering, now you can see the loss graph, training validation, and sorry, model training and model validation. Here, the MSC train and the MSC validation. So here we have 6.55. That's it. So when you get a chance, take the solution and download locally if you need it. That's what I typically do all the time. Download it here for now. Save. That's the end of the lab. So let me close everything and end the lab. And thank you for joining.